Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Interface Python with SQL, Part 3, TCL Commands, Commit, Rollback, AUTOCOMMIT, SAVEPOINT, Read Operation, fetchone, fetchall, fetchmany of, size, rowcount, selection using where clause with practical implementation, for the class 12 students of computer science. So, let's dive in and get started. SQL is the language used to interact with the database. The SQL statements or commands that we type are the statements that are regarded as the instructions to the database. SQL provides different types if statements for different purposes. We have already discussed about DDL, DML, DQL in our previous video, Relational Database and SQL. Now, we are going to discuss about TCL. So, what is TCL? TCL is Transaction Control Language. TCL is used to manage transactions within a database. It includes commands like commit, to save changes, and rollback, to undo changes, ensuring the integrity and consistency of data in a database during transactions. TCL is Transaction Control Language. TCL is used to manage transactions within a database. What is a transaction? A transaction refers to a logical unit of work that is performed on a database. It is a sequence of one or more database operations, such as inserts, updates, deletes, or queries, that are executed as a single, indivisible unit. TCL includes commands like commit, to save changes, and rollback, to undo changes, ensuring the integrity and consistency of data in a database during transactions. So what is a SAVEPOINT? Imagine you're working with a lengthy table, and you want to roll back only to a specific point within that table. This is where SAVEPOINTs come in handy. A SAVEPOINT allows you to mark a particular position in a transaction. Later, if you need to roll back to that specific point, you can do so easily using the SAVEPOINT's name. Essentially, a SAVEPOINT acts as a bookmark within your transaction. AUTOCOMMIT. AUTOCOMMIT in databases automatically saves changes made to the database after each individual SQL statement is executed. AUTOCOMMIT mode automatically commits each SQL statement as a separate transaction. Start transaction allows you to group multiple SQL statements into a single transaction and provides more control over transaction boundaries and error handling. Testing TCL commands in MySQL. To test TCL commands, you typically have two options. Disable AUTOCOMMIT. You can disable AUTOCOMMIT to manually manage transactions using TCL commands. This allows you to group multiple SQL statements into a single transaction. Or, use Start Transaction. Alternatively, you can use Start Transaction to explicitly begin a new transaction, even if AUTOCOMMIT is enabled. This also allows you to group SQL statements into a transaction. Demonstrating a simple transaction where a single SQL operation is executed within a transaction and committed. Let's open the MySQL prompt. We shall use Start Transaction statement. Look at the blue box. In the MySQL prompt, we type the statement, Start Transaction, semicolon. So, it will disable the AUTOCOMMIT, still you close this window. Now, look at the yellow box. We type the statement, Use Academy semicolon. This command selects the Academy database for use. It sets the current database context to Academy. Now, look at the green box. We type the statement select star from student semicolon. This command retrieves all rows and columns from the student table. It displays the current contents of the student table, showing the roll numbers, names, ages, and cities of the students. Now, look at the blue box. In the MySQL prompt, we type the statement, update student set age equals 19 where roll number equals 2 semicolon. This command updates the age of the student with a roll number of 2 to 19. It specifies the condition where roll number equals 2, meaning it only updates the row where the roll number is 2. Now, look at the yellow box. We type the command commit. This command confirms the transaction. In MySQL, unless you are using explicit transactions, begin, commit, rollback, each individual SQL statement is treated as a transaction by default. So, the commit statement finalizes the transaction, making the changes permanent. Now, look at the green box. This command retrieves all rows and columns from the student table again. It displays the updated contents of the student table, showing that the age of the student with roll number 2 has been successfully changed to 19. This MySQL session demonstrates the usage of transactions with the start transaction and rollback commands. Look at the blue box. In the MySQL prompt, we type the statement start transaction, semicolon. This command begins a new transaction. Transactions are used to group one or more SQL operations into a single unit of work that either fully succeeds or fully fails. When a transaction starts, MySQL retains the changes made by the transaction until they are either committed or rolled back. Now, look at the yellow box. We type the statement, update student set age equals 21 where roll number equals 5 semicolon. This command updates the age of the student with a roll number of 5 to 21. Remember, in the last transaction, roll number 5, Steve's age was 20. It specifies the condition where roll number equals 5, meaning it only updates the row where the roll number is 5. Now, look at the green box. We type the statement, select star from student, semicolon. This command retrieves all rows and columns from the student table. It displays the current contents of the student table after the update operation, showing that the age of the student with roll number 5 has been successfully changed to 21. Now, look at the pink box. We type the command, rollback semicolon. This command rolls back the changes made during the current transaction. In this case, the change made by the update statement, changing the age of the student with roll number 5 to 21, is undone, reverting the data back to its state before the transaction began. Now, look at the orange box. Select star from student, semicolon. This command retrieves all rows and columns from the student table again. It displays the contents of the student table after the rollback operation, showing that the change made by the update statement has been reverted, and the age of the student with roll number 5 is back to 20, as it was before the transaction started. Now again let's revise. The transaction started with the start transaction command, an update operation was performed, but then it was rolled back using the rollback command, ensuring that the changes made during the transaction were not permanently applied to the database. Introducing more complex transactions involving multiple SQL operations, using start transaction, commit, rollback and SAVEPOINT. Look at the blue box. In the MySQL prompt, we type the statement, start transaction, semicolon. This command begins a new transaction. Look at the yellow box. We type the statement, update student set age equals 22 where roll number equals 3 semicolon. This command updates the age of the student with a roll number of 3 to 22. Look at the green box. We type the statement, select star from student, semicolon. This command retrieves all rows and columns from the student table. It displays the current contents of the student table after the first update operation. Look at the pink box. We type the statement, SAVEPOINT update _ SAVEPOINT semicolon. This command sets a save point within the transaction. Save points allow you to mark a point within a transaction to which you can later roll back. Look at the orange box. We type the statement, update student set age equals 21 where roll number equals 4 semicolon. This command updates the age of the student with a roll number of 4 to 21. Now, look at the blue box. We type the statement, select star from student semicolon. This command retrieves all rows and columns from the student table. It displays the current contents of the student table after the second update operation. The age of the student Emeka, with a roll number of 4 to 21. Look at the green box. We type the statement, rollback to update _ SAVEPOINT . This command rolls back the changes made to the save point. In this case, it will revert the changes made after the save point was set. So, the update made for roll number 4 will be undone. Look at the orange box. We type the statement, select star from student . This command retrieves all rows and columns from the student table. It displays the current contents of the student table after the rollback operation. So what do we see here? The age of the student Emeka with roll number 4 is 16 now. Here is the previous screen. Look at the green box. Roll number 4, Emeka's age is 16. Yes, it has rolled back. Now, look at the purple box at the bottom of the screen. We type the command, commit . This command commits the transaction, making all changes made within the transaction permanent. Since no changes were committed due to the rollback, the commit operation doesn't affect the database. Let's revise. Save points provide a way to partially roll back a transaction. In this session, a transaction was started, 2 updates were made, a save point was set, 1 more update was made, then the changes made after the save point were rolled back. Finally, the transaction was committed, but since no changes were left to commit, it had no effect on the database. Python MySQL connector provides the following methods to manage database transactions in Python. First is the commit method. Commit is a database command used to permanently save the changes made during a transaction to the database. Once a program has completed executing the query with your changes and you want to commit the changes to the database, then you need to call commit method on MySQL connection object. Syntax is connection.commit function. Next method is rollback. Rollback is a database command used to undo changes made during a transaction and restore the database to its state before the transaction began. When one of the transactions fails to execute and you want to revert or undo all your changes, then you need to call a rollback method of MySQL connection object. Syntax is connection.rollback. Next is AUTOCOMMIT. AUTOCOMMIT in databases automatically saves changes made to the database after each individual SQL statement is executed. AUTOCOMMIT means that whenever you run a command that changes the database, like inserting data or updating a record, it's automatically saved without needing you to specifically tell the database to do so. Syntax is connection.autocommit function. MySQL connection.autocommit function value can be assigned as true or false to enable or disable the autocommit feature of MySQL. By default, its value is false. Let's focus on the use of commit and rollback method in detail. Program to update the age of a student named Alex and commit it to the database. This Python script connects to a MySQL database, updates the age of a student named Alex to 20, and then commits the changes to the database. Look at the Python code. First line, we are importing MySQL.connector. Second line, we are connecting to the database. Adjust these parameters according to your database configuration. On the third line, we are creating a cursor. Now, look at the fourth line. Updating the database. X equals update candidate set age equals 20 where name equals Alex. The script defines an SQL query string X that updates the age column of the candidate table. It sets the age to 20 for the student named Alex. Next line, we are executing the update query. The execute method of the cursor is called with the SQL query string X as an argument. This executes the SQL query against the database. Finally, we are committing the changes. The commit method is called on the connection object to commit the changes made by the update query to the database. This ensures that the changes are permanent and not just temporary. Thus, this script connects to a MySQL database, updates the age of a student named Alex to 20 in the candidate table, and then commits the changes to the database. Now save and run the file. Let's open the MySQL prompt. Look at the yellow box. We type the statement, select star from candidate semicolon. When pressed Enter key, you can see roll number 3 name Alex age has updated to 20. The original table is in the red box, the age of Alex was 18. This code shows the use of rollback method to revert changes if a database transaction fails. Look at line 1. We are importing MySQL.connector module. In the second line, from MySQL.connector import error, imports the error class, which represents exceptions raised by the MySQL connector module, facilitating error handling in database operations. Similarly, in line 3, from MySQL.connector import error code, imports the error code dictionary, mapping MySQL error codes to human-readable error messages, aiding in error diagnosis and handling. In the next line, we are using try-except construct. The try-except construct is used in the provided code to handle potential errors that may occur during the execution of database operations like error handling, exception catching, rollback on error, etc. In the fifth line, we are establishing a connection. The code connects to a MySQL database named Academy running on localhost with the provided credentials. In the sixth line, we have the cursor creation. A cursor is created to execute SQL queries. Update operation. An SQL update statement is executed to change the age of the candidate named Alex to 20. After this operation, the table will look like this. The age of Alex is updated to 20. Now look at the blue arrow. Commit changes. CONN.commit function. The changes are committed to the database. In the next line, this print statement serves as a confirmation message indicating that the database update operation was successful. It provides feedback to the user or developer that the intended operation, in this case, updating the database, has been carried out without encountering any errors. Next, look at the 3 lines within the red bracket. Yes, it is error handling. If an error occurs during the execution of the code block, it will print an error message and roll back any changes made since the last commit. In this example, if the update fails for any reason, it will revert the age of Alex back to its original value. If the update fails for any reason, it will revert the age of Alex back to its original value. You can see the original values of Alex's age as 18. That is the meaning of rolling back. It reverts back the original value again. Look at the last line. CONN.close function. Finally, the connection to the database is closed. Now save and run the file. What can you see? Yes, if the database transaction is successful, the output will be database updated. Let's discuss about the read operation. Read operation on any database means to fetch some useful information from the database. Once our database connection is established, we are ready to make a query into this database. We can either use fetchone method to fetch a single record or fetchall method to fetch multiple values from a database table. Let's see the fetchone method. Fetchone fetches one row from the result set to the form of a tuple or a list. A result set is an object that is returned when a cursor object is used to query a table. This function shall return one record from the result set. That means, first time it will return the first record, next time it will return the second record, and soon. If no more record is left in the table, it returns none. Next method is fetchall function. Fetchall function fetches all the rows in a result set and returns a list of tuples. If some rows have already been extracted from the result set, then it retrieves the remaining rows from the result set. If no more rows are available, it returns an empty list. Next method is fetchmany of size function. fetchmany of size function fetches the specified number of rows, as a list of tuples, from the result set. The default size is 1. If there are no rows in result set, an empty list function is returned. That means it will return an empty list. Rowcount. Rowcount is a read-only attribute and returns the number of rows that were affected by an execute method and retrieved from the cursor. Let's work out some examples of the read operation. To display all the records of student table using Python shell, open a new file in Python shell and type the statements. Look at line 1. Line 1 imports the MySQL.connector module, which provides the necessary functionality to interact with MySQL databases from Python. Line 2 establishes a connection to the MySQL database. Adjust these parameters according to your database configuration. In the third line, we are creating a cursor object, myCursor, using the connection CONN. A cursor allows you to execute SQL queries and fetch data from the result sets. In the fourth line, we execute a select query that retrieves all columns from the candidate table in the Academy database. Now, look at the fifth line, myRecords equals myCursor.fetchall function. This line fetches all the rows from the result set generated by the previous select query and stores them in the myRecords variable. Each row is represented as a tuple. In the sixth line, we are using a for loop. For x in myRecords: print x. This loop iterates over each tuple of x in the myRecords list and prints it. Each tuple represents a row from the candidate table, with the values of each column in that row. Now save and run the file. In the Python code, we have used select statement along with fetchall function. This function is used to read and display all the records as tuples from the table candidate. Let's work out the next example. To display all the records along with the total number of records from student table using Python shell, open a new file in Python shell and type the statements. Look at line 1. This line imports the MySQL.connector module, which provides the necessary functionality to interact with MySQL databases from Python. Line 2. This line establishes a connection to the MySQL database. Adjust these parameters according to your database configuration. Line 3. This line creates a cursor object, myCursor, using the connection CONN. A cursor allows you to execute SQL queries and fetch data from the result sets. Line 4. This line executes a select query that retrieves all columns from the candidate table in the Academy database. Line 5. myRecords equals myCursor.fetchall function. This line fetches all the rows from the result set generated by the previous select query and stores them in the myRecords variable. Each row is represented as a tuple. Line 6. No underscore of underscore records equals myCursor.rowcount. This line retrieves the number of records fetched from the result set using the rowcount attribute of the cursor object. Line 7. This line prints the total number of records found in the result set. Line 8. For x in myRecords: print x. This loop iterates over each tuple x in the myRecords list and prints it. Each tuple represents a row from the candidate table, with the values of each column in that row. Now save and run the file. This program is a modification of the previous implementation. It displays the total number of records retrieved from the table candidate apart from all the records being displayed. The number of records fetched is displayed using the attribute of the cursor object. That is rowcount. This attribute counts the number of records retrieved from the table and the output shows the total number of records as 5, which are also displayed alongside. Let's learn how to display records from the candidate table, one at a time, using fetchone function. Open a new file in Python shell and type the statements. Line 1. This line imports the MySQL.connector module, which allows Python to interact with MySQL databases. Line 2. This line establishes a connection to the MySQL database. It requires parameters like host, the location of the database server, user, username to access the database, password, password for the specified user, and database, the name of the database you want to connect to. Adjust these parameters according to your database configuration. Line 3. This line creates a cursor object, which is necessary to execute SQL queries on the database. The cursor acts as a pointer to a specific location within the database. Line 4. MyCursor.execute, select star from candidate. This line executes an SQL query to select all records from the candidate table in the connected database. Line 5. MyRecords equals MyCursor.fetchone function. This line retrieves the first row of the result set returned by the SQL query and stores it in the MyRecords variable. Line 6. No_of_records equals MyCursor.rowcount. This line retrieves the number of rows affected by the last executed SQL statement and stores it in the no_of_records variable. Line 7. This line prints the total number of records found based on the previous SQL query. Line 8. Print MyRecords. This line prints the content of the first row retrieved from the candidate table. Line 9. This line prints a separator to visually distinguish between the first and second fetch. Line 10. MyRecords equals MyCursor.fetchone function. This line retrieves the next row of the result set returned by the SQL query and stores it again in the MyRecords variable. Line 11. No_of_records equals MyCursor.rowcount. This line again retrieves the number of rows affected by the last executed SQL statement, which in this case would be 1 if there's another record fetched. Line 12. This line prints the updated total number of records found based on the subsequent fetch. Line 13. Print MyRecords. This line prints the content of the second row retrieved from the candidate table, or none if there are no more rows to fetch. This code essentially connects to a MySQL database, executes a query to fetch records from a table, retrieves and prints the records, and then fetches and prints the next record. It repeats this process until there are no more records to fetch. Now save and run the file. Now, look at the output. Total number of records found are 1. This line indicates that after executing the SQL query select star from candidate, 1 record was found in the candidate table. The next line represents the content of the first row retrieved from the candidate table. It shows the values for each column in the table for this particular record. Total number of records found are 2. This line indicates that after fetching the next record, the total number of records found in the candidate table increased to 2. The next line represents the content of the second row retrieved from the candidate table. It follows the same format as the first row, with values corresponding to the columns in the table. Until the last implementation, we fetched and displayed all the records from the candidate table. In this implementation, we are using fetchone method to fetch and display the records from the table one by one or one at a time. Let's learn how to display n number of records from the candidate table using fetchmany n. This program shall fetch and display n number of records from the candidate table through fetchmany of n method by passing the number of records to be retrieved as n. Open the Python shell and start typing the statements. Line 1. This line imports the MySQL.connector module, which provides functionality to connect and interact with MySQL databases from Python. Line 2. This line establishes a connection to the MySQL database. Line 3. This line creates a cursor object MyCursor, which is used to execute SQL queries on the connected MySQL database. Line 4, MyCursor.execute, select star from candidate. This line executes an SQL query to select all records from the candidate table in the connected database. Line 5, myRecords equals mycursor.fetchmany of 3. This line fetches at most 3 rows from the result set returned by the SQL query and stores them in the myRecords variable. Line 6, no underscore of underscore records equals mycursor.rowcount. This line retrieves the number of rows affected by the last executed SQL statement and stores it in the no underscore of underscore records variable. Line 7. This line prints the total number of records fetched from the candidate table. However, as mentioned earlier, rowcount may not accurately represent the number of fetched records. Line 8, for row in myRecords: print, row. This loop iterates over each row in myRecords and prints each row. Each row is a tuple containing the values of the columns for that particular record. Let's revise. This code connects to a MySQL database, fetches at most 3 records from the candidate table, and then prints those records. However, please note that the accuracy of rowcount for select statements in MySQL may vary, so it's not always reliable for counting the number of fetched records. Now save and run the file. The output shows that 3 records were fetched from the candidate table, each with different candidate information. Each row of the output corresponds to 1 record fetched from the database. In this program, 3 has been passed as an argument to fetchmany method, and hence, the output displayed shows first 3 records from the candidate table. We can retrieve selected records from the table using where clause in Python shell also in the same manner as is done in MySQL. Let's see an example. To implement where clause using Python interface. This is to be implemented using MySQL, select where statement in Python script. Let's open a new file in the Python shell and type the statements. Line 1. This line imports the MySQL.connector module, which provides functionality to connect and interact with MySQL databases from Python. Line 2. This line establishes a connection to the MySQL database. Line 3. MyCursor equals CONN.cursor function. This line creates a cursor object MyCursor, which is used to execute SQL queries on the connected MySQL database. Line 4. MyCursor.execute, select name, age, marks from candidate where city equals New York. This line executes an SQL query to select the name, age, and marks columns from the candidate table where the city column is equal to New York. Line 5. MyRecords equals mycursor.fetchall method. This line fetches all the rows returned by the SQL query executed earlier and stores them in the myRecords variable as a list of tuples. Each tuple represents a row from the result set, and each element within the tuple corresponds to a column in the result set. Line 6. For x in myRecords: print x. This loop iterates over each tuple in myRecords and prints it. Each tuple contains the values of the name, age, and marks columns for a candidate from New York. The output of this loop is a list of tuples, each representing a candidate's information, name, age, and marks, who resides in New York. The output will display the information of all candidates from New York with columns name, age, and marks. Each row will show the name, age, and marks of a candidate meeting the conditions specified in the SQL query. Now save and run the file. The output, Emily, 1586, corresponds to one of the rows fetched from the MySQL database based on the SQL query select name, age, marks from candidate where city equals New York. In the where clause, we have used city equals New York, that means, to fetch the records of all the students who are staying in New York City. Since there is only one record in the table that matches with the given criteria, it is displayed as shown on the screen. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos, Interface Python with SQL, Part 4. Parameterized queries, concatenating dynamic variable to a query, string template with %s formatting, string template with format string method and format function. Inserting, deleting and updating records, closing cursor and connection. You can check the link in the description box given below.